Hi, my name is Dave Lanning. I am the Vice President of Forest Concepts, and today I want to talk to you about the Crumbler Rotary Shear. This is a pretty cool piece of equipment that we developed for biomass processing. Now, I do want you to remember that you and I are biomass, so don't put your fingers in because you don't want to be turned into small little bits and pieces. That's why I have done a lockout on the control so it can't possibly be turned on while we're talking about it. So what it is a rotary shear. This particular model is our M24S-30E. It's an M series, which means it's got smaller 4-inch diameter cutters. It is a 24-inch wide processing head with a 30 horsepower electric motor. This particular model, the S model, is set with an in-feed coming in. Material drops through the processing head, which sits in this box right here, and then moves on downstream. What is cool about this is, well, many things, honestly, but this particular one, the processing heads are removable, and you can quickly swap them out to change material output sizes. We make a really uniform flowable material coming through the rotary shear. Why you might like that is because you don't want to plug up your airlocks and your augers and any of that downstream material handling mechanisms. We don't plug or bridge in hoppers. We make materials that are flowable and ready to go. We also have here a M24M-30E 2 modular stack. Crumbler heads go in here, but this just goes to show that we have different configurations that you can have sequential processing through a couple of different processing heads that will fit into a more industrial application than the M24S that we talked about earlier. So let's talk about the head. Here, zoom in right here. Zoom in. There's no head right there because this one's not ready, but we're gonna cut to that right now. So here in our processing lab at our Auburn, Washington headquarters, we have multiple processing heads to be able to control the particle size through the rotary shear crumblers. So, for example, this is a processing head. It's super easy to get in and out to change. You just have 4 bolts. You pop the head out, then put your new one in. That allows you to do all of your maintenance offline, so there's literally 0 downtime in your production. We control particle size, and this is the cool part, by changing the cutter thickness. So you see these ones are roughly 1/4 inch or 250 thousandths or roughly 6 millimeter-ish. So this is a M series, again, 4-inch diameter cutter with 1/4 inch cutters. So you have an HP 24-250 for this size processing head. Now, again, we control particle size by changing cutter size. So this set, which normally they don't sell with these wood blocks, but again, research facility. This looks like it's a 42 thousandths size head. So this is the smallest that we go. It makes a 1.5 millimeter geometric mean diameter size particle or so. This one is a 3/16 or a 1/88 size head. Now you'll notice that you've seen some different tooth geometries on these. The teeth themselves don't actually do the cutting or the processing. What they do is grip and pull the material in. So we match the aggressiveness of the teeth. So if you look at the short teeth, the long teeth, we match the aggressiveness of the teeth to the materials being processed. If you have too aggressive teeth, you can pull in too much material and you stall out the motor, run out of power. If you don't have aggressive enough teeth, you can't pull in enough material and you can never actually overload or load the motor to its full capacity. So that's one of the things we do when we are working with you as a customer, is that we'll figure out what you're processing, how you're gonna process it, what you need to get to so we can match the entire system to your end product. So here we have several quite worn cutters of the 0.63 or 16th inch size material. While our processing heads do just look like they are beefy paper shredders, they kind of are, but there's a little more nuance to that. So what we have is material or cutters that stack and overlap, and that's how you get the shearing. So it's like a set of scissors, but they're round. That's why we call it a rotary shear. And so material comes in through the middle, it gets nipped and pulled as the cutters spin around, and that's what shears the material. So you end up with a super uniform particle coming out. You know that a particle will be at most in one dimension the thickness of the cutter. The other dimensions are going to be dependent on grain orientation and material thickness to start with. What is pretty cool is that when you have, and this is part of the cool secret, don't tell anybody, okay? When you shear across the grain of a particle, internal loading, or Poisson's forces if you're an engineering nerd like me, will do internal stresses that cause herbaceous and woody materials, particularly like woody with the grain structures like that, to be able to fail perpendicular to grain at about the thickness of the cutter. So you end up with really cubic particles that come out. And that's really cool because cubes are more like marbles. Marbles flow well, pencils don't. So you want to have that low aspect ratio particle. And that is part of the cool thing about the Crumbler. So up to this point, I've been talking about our M series machines. They have 4-inch diameter cutters, so they're a little bit smaller. They're good for pilot systems. We also have P series machines that use 8-inch diameter cutters. They are more commercial applications where you're pushing a lot more material through the system. I don't have any here because, quite frankly, I don't have enough power into our development unit here in Auburn to be able to efficiently run a P series system. On top of that, you can push up to 10 to 15 tons, oven-dry tons an hour equivalent of material through the system, which will just overflow our small storage capacity here. Something I don't think I mentioned earlier is that rotary shears are really cool that they can process high moisture content materials rather than having to go through a dryer and then through your size reduction like a hammer mill. You can do your size reduction first, get that super uniform particle that's small, and then go through your dryer. And that dramatically reduces your dryer energy consumption and your dryer size because it takes less time to get heat to the middle of the particle and the moisture back out of the particle. So doing size reduction before drying when you're going to a dry process is really economically beneficial to your end product and end system.